The majority of electricity in the United States is consumed in offices and commercial buildings that utilize disparate systems and lack efficiency. Cisco's emerging technology of smart connected buildings offers an integrated solution system that utilizes the power of the CISCO Network Building Mediator. This networked sustainability platform offers an innovative opportunity to reduce energy while significantly impacting global energy efficiency.
Our business unit was formed about a year and a half ago in the name of smart buildings, connected buildings. And the problem that we see is energy. The energy is the driver, coupled with the mandates for our environmental reductions of carbon. But we are focused on commercial buildings that consume anywhere from 40 to 60% of our electric energy in North America. So they're huge guzzlers of energy. And these buildings are traditionally not managed from an energy perspective very well. So we see as a great market being able to go into these buildings and connect them to network, connect them together, bring the value of the network and the applications that could be put onto the network to drive energy reductions and actual carbon reductions in buildings. And we build technology to do this smart building. And the technology involves a product that looks like this. It's called a mediator. This is the Cisco version of it today. And it has what we call, you can see it's essentially a very slender device. It's analogous to a multi-protocol router in the networking world. But it has lots of connections to connect into what we call Southside building systems. And these building systems are meters, water, gas, electric, HVAC systems, photovoltaic systems, maybe if it's some sort of clean tech. And so all these systems come from a whole different legacy of manufacture, protocol, physical connections, and different agendas from different companies. And they all exist in some form or factor in buildings today, and we bring those in through integration, and we move their content and interaction up onto the network, up onto the traditional IP network in a building. So when we can take all these various disparate systems that are in a building and bring them into a common viewpoint and actually deliver them up onto the network and have one application, or many different applications, but that can consume that data, we now find ourselves being able to form what we call an intelligent building. It's very simple applications of intelligent building are, do the lights work with the HVAC? Are they integrated? Traditionally, they're not. Typically, light switches turn the lights on, and there's a thermostat that turns the HVAC on and off, and they're not integrated. So lights produce heat, and air conditioning is there to cool it. So if they're not integrated, you're wasting energy. So we see buildings consuming, wasting 30% of their energy right off the bat by virtue of building systems not being controlled or managed properly. The way the industry has delivered the buildings, it's just been the evolution. They delivered them more in point solutions. One system that does my metering, my HVAC system, one system for that, one for lighting, and those systems aren't traditionally integrated. So what we want to do is bring them together so they can share data between themselves and build what we call more of a network, of a platform that now looks at all of that data the same. So from a sustainability perspective, we believe that if we can have these buildings, all their data coming out of them now, out of these disparate systems, onto the network, we could have this on all the time. And essentially on all the time allows us to then start to be able to do some management back down through, since we're bi-directional. We can control back down into the buildings. So this becomes the beginning of sustainability, is when we can monitor all the time and actually make changes to the building and see the results immediately, and continually commission and tune these buildings to make them more and more energy efficient. Right now, buildings consume electricity. There's a power meter there to record how much you use so you can get a bill for it, so the utility can bill you. But really, the electricity is allocated onto the grid to a substation, to buildings. And if that energy is not used the same way it was allocated, it turns into heat and it's wasted. And so If we can get into a just-in-time type of supply and demand, a balance, where these smart buildings are actually waking up every second and saying, hey, I need this much energy, and the market is servicing them somehow with that much energy. So if we could balance supply and demand equally, we would find gigantic efficiencies and go up and costs go down. They can be customized from a graphical representation, web view, different kinds of control logic, different kinds of services. One service may be a service where we're asking the utility, maybe it's PG&E, we're asking the utility every 10 seconds for its price of electricity or its trigger for some sort of a demand response event. And we would consume that and run it through the automation process that's on board and tell a air conditioning system to change its set point and measure that result of that energy reduction through a meter that's plugged into here, and then send log that as a trend, and then send that back to the utility so they would know exactly how much energy they saved at that trigger of a demand response. So the applications become very, very open-ended, and we believe a platform approach is what the industry of these buildings really needs today in order to really drive the sustainability model.